Okay, so in today's notes, what we're going to do is we are going to go through how to factor quadratic equations that now might have a leading coefficient of 1, of greater than 1. What we've been working with are quadratic expressions or equations where the coefficient every time was 1, but we're actually going to look at in this section situations where it's greater than 1. So let's start right here. To factor the form ax squared plus bx plus c, in the last lesson, we factored these just by, a was 1 every time. This right here, this number out front was never anything other than 1, but that's not always the case. The way we do this, if we take a look at the dimensions of the rectangle formed by the algebra tiles are the factors of 2x squared plus 5x plus 3. So if we were to factor this, I can just tell you, we would get x plus 1 and we would get 2x plus 3. Now we can FOIL that and check it, and it's pretty easy to see. Okay? What we do is we do basically the same exact thing, but instead of in last section, we found two numbers that added up to the middle term and multiplied to the last term. This time, the only change is that instead of multiplying to the last term, we're going to find numbers that multiply to the product of those two terms. Okay? So we're going to take 2 times 3 and get 6. So we're going to find two numbers that multiply to 2 times 3 and add to the middle term still. That part, there's no difference. Okay? We want the sum of the factors to be the middle term, but we need the factors that we're looking at to be the product of the first and the last. So if we take a look here, what we're able to do is, and some of you will do this in your head and some of you won't, but I'll show you how we're doing this. The reason we've been doing factoring by grouping this whole time is that we can take 2x squared plus 5x plus 3. We know that 2 times 3 is 6 and 2 plus 3 is 5. So we can take this middle term, and what we're going to do is we're going to separate it. Instead of writing 5x, we're going to write 2x plus 3x. I think we would all agree, hopefully, that 2x plus 3x is 5x. So all we've done is changed the way that the problem looks. We haven't changed the way, or changed the value of the problem. Once here, we're going to factor by grouping, something else we've already done. Okay, group terms with common factors. So 2x squared plus 2x plus 3x plus 3. Then we're going to do an actual factoring by grouping. Here we can factor out a 2x and we have x plus 1. Here we can factor out a 3 and again we have x plus 1. We said when we did this earlier that if we've done this correctly, those two terms will be the same. Then we can factor out an x plus 1 and a 2x plus 3. Okay? It's the same concept. It's this part right here, this new step right here that's a big deal that we have to understand. Pay no attention to the arrow facing the wrong direction. The sound effects on this thing are insane. The big difference is this part, that we're going to multiply 2 times 3, okay, and get that 6. And that's how we ended up down here, knowing that we were going to find factors of 6. Okay, so let's take a look at an example. And again, the key concept here is that we can separate, for another example, 5x squared minus 13x plus 6 is the same as 5x squared minus 10x minus 3x. These two terms right here, minus 10x and minus 3x, combine to make this term. So we've just changed the way it looks. Then we can factor by grouping, and again, if we've done these right, we can see we get x minus 2, and then we can factor out the x minus 2. Okay? So let's look at some. We have 7x squared plus 29x plus 4. When the coefficient, when that first number up front is greater than 1, so right here we have a 7, we're going to multiply 7 and 4. So let me get this handy dandy who's a what's it over here. We're going to multiply 7 times 4. That's pretty cool. We're going to multiply, got distracted by my artwork. That sound again. 7 times 4 is 28. So we're looking at factors of 28 that we want to add to 29. Okay, still adding to this middle number. Once we do that, we separate them down here. 1x and 28x add up to 29, and they are factors of this product up here at the top. Okay. So then we're going to factor by grouping, and here we can factor out an x, get x plus 4. Here we can factor out a 4. We can factor out an x and we get 7x plus 1. A 4 here and 7x plus 1, and so there is our answer. Same sort of thing happens down here, where we have 3x squared plus 15x plus 18. We can change, this is a big thing. We talked about this previously, where we have got to always check if there's a GCF. Okay, we've talked about this, I mentioned this in class last time, but we really need to stress it. If there's a greatest common factor that we can factor out, you've got to do that first. Just because the leading coefficient is greater than 1 doesn't mean that you're always going to do this factoring by grouping. Sometimes it means that we can factor out the GCF of 3, and then we have an easier one that we've been working on, where we can just change that to x, factor that, and get x plus 3 times x plus 2. Alright, let's take a look. So, study tip, just a reminder, always checking to see, can I look for a GCF? Is there a GCF? So let's do these together. We'll do them out loud. Is there a GCF between 5x squared plus 13x plus 6? Well, is there? No, I couldn't find one either. So the first thing we're going to do is, yeah, you guessed it. We're going to multiply 5x times 6, okay, or 5 times 6. When we do that, we get 30. So now I have 30. That's the number. I'm looking for two numbers that multiply to 30 but add to 13, okay? Two numbers that multiply to 30 and add to 13. So let's start making our list. Factors of 30. So 1 and 30, 2 and 15, 3 and 10. I can stop now. Okay, I know that these add up to 31, these add up to 17, these add up to 13. This is the kind of stuff that as you get better at this, you'll probably start doing some of these things in your head. Alright, so I know that the one that I want is this one here. Okay, they add up to 13, so that's the one I want. So now I'm going to rewrite this, and I'm going to rewrite it as 5x squared plus, and it doesn't matter which order we do these. We could do 3 first, we could do 10 first, it doesn't matter. I'll do 3 this time. Plus 3x plus 10x plus 6. It's still at 6 from the beginning. All we've done is change the way that it looked in the beginning. Now we're going to start to factor. The common factor, by grouping, the common factor here in this first group is just x. 5 and 3 are both prime numbers. So if I factor an x out, I'm left with 5x plus 3. Plus, and then the common factor here, these are both just even numbers. Their common factor is 2. And here I'm again left with 5x plus 3. I've done it correctly. I know that because I have the same pair right here. This binomial is the same twice. Then I'm going to separate them, and I'm going to have 5x plus 3 times x plus 2. And again, much like all the problems we've done here, you're welcome to check your answer by using FOIL or the grid method or your graphing calculator, any way that you like, to check your work. Some big things to keep an eye on, common mistakes students make. This was 5x squared, so this is 5x squared. Okay, we want to make sure those match up. This is 6, this is 6. The only real change, okay, the only real change is that we went from 13x to 3x plus 10x. That was the only difference. And after that, we did factoring by grouping, which is a skill that we've already practiced. All right. Let's take a look at the second one. The second one is a little bit of a different problem because it says right here, study tip. God, I love abstract art. Look at that. Beautiful. It says right here that I always want to check for a GCF. Well, 6, 22, and 8 are all even numbers. So the first thing I'm going to do is I'm going to factor out a 2. So 2 times, I'm left with 3x squared plus 11x minus 4. Okay, now I need to factor that. So we're looking for two numbers that multiply And remember, we got to use this again. We have to use this right here. Two numbers, we got to multiply those two together. So two numbers that multiply to negative 12, but add to 11. Okay, that's the middle number. Two numbers that multiply to negative 12 and add to 11. All right, so that's what we're looking for. So let's make a list of our numbers. Negative 12, factors of negative 12. Well, we have 1 and negative 12. And I would immediately notice that that adds up to negative 11. If I change the sign on it and make it negative 1 and 12, I've got what I was looking for. 3 and 4, 2 and 6, those are obviously all factors of 12 also, but I can stop because I've got what I want now. So I'm going to rewrite this up here. 2 parentheses 3x squared is going to be minus 1x. Okay, and actually we did the 1x by itself over here on the one on the left. So we'll do plus 12x. Plus 12x. Hey now, that's not what we wanted. Plus 12x minus x minus 4. And again, the only thing that we've done, okay, is we've changed this 11x to 12 minus x. 12 minus x is 11x, so we've just changed the way that it looks. On the next line, we're going to factor by grouping. So now I have 2 parentheses, and then this we could make it brackets or double parentheses, whatever you like. We're going to factor by grouping. 3x squared and 12x both have a 3x in common. What's left? X plus 4. Then I see that I have negative x minus 4, but I also see that right here this is x plus 4. They're basically the same except for these are negatives, so let's factor out a negative 1. And I'm left with, well, looky here, x plus 4. Isn't that spectacular? Now I'm going to go to the next line. I'm going to make sure my parentheses, I have the right amount. I have 1, 2, 3 right parentheses and 1, 2, 3 left parentheses, so I'm all set. Then I'm going to get my finished product. 2 times the quantity, 3x minus 1 times the quantity, x plus 4. And that's it. Okay, that is finding the greatest common factor and then factoring a quadratic that does not have a leading coefficient of 1. Let's take a look at the next page. Again, just like with the previous set of these where we had, they were all leading coefficients of 1, they're just going to look different depending on sometimes plus plus, sometimes, and I'm talking right here just for those of you that need to see, this one's minus plus, sometimes it's plus plus, sometimes it's minus minus, sometimes it's plus minus. The concept is still the same. We're going to multiply this 3 times 20. You can see right here, it was 3 times 20. All right. 3 times 20, and that's how we got our 60 right here. Okay, and then the negative 17. So that's how, right there, this negative 17x was changed to minus 12x minus 5x. After that, the factoring by grouping is still the same. All right, so let's take a look. Let's take a look. Well, I bet you can't see that. And now you can probably see it. And we can go a little bigger. Alright, so let's take a look at these two. We'll do these together also. 2n squared minus n minus 1. Well, 2 times negative 1 is negative 2. So I'm looking for numbers that multiply to negative 2 and add to negative 1. Well, that's pretty easy. Multiply to negative 2 and add to negative 1. How about negative 2 and 1? Those multiply to negative 2. Those add to negative 1. So let's change that problem. Okay, let's change this problem to 2 times n, whoopsie daisy, 2n squared minus 2n plus n minus 1. Now remember, all we've done is we've changed that middle, we've changed that middle term. That's all we've done. Okay, we've changed minus n to negative 2n plus n, which is the same thing. Then we're going to factor by grouping. And we're going to have, in that first pair, we can factor out a 2n. And we're left with n minus 1. On the second grouping, we already have n minus 1, so I don't need to factor out anything. But I still have to put something here, so plus 1. Anything times itself is itself, so that works for us. And it gives me n minus 1 here and here. Remember, I want those to be the same. So Now I can rewrite 2n plus 1 times n minus 1. And don't forget, you could FOIL any of these answers or use any of the methods that you like to check them. Let's take a look at this one. Hopefully some of you right away have noticed that on this next problem, what do you have? 10, 35, 30, all numbers that are divisible by 5. So 5 is a greatest common factor. We're always going to factor out a greatest common factor first if we can. So 5 leaves us with 2y squared minus 7y and plus 6. Now some of you may be wondering, like, Mr. Emmer, I'm getting pretty good at this. I don't want to do all these steps over here. I don't want to do all this part. Is there any way we can skip it? Sure you can. If you're starting to get comfortable and you want to start guessing at some of these answers and functioning under basically just a guess and check method like using FOIL, you're welcome to do that. That's how I do it. That's how most people who are really good at adding and subtracting and multiplying do these problems. So I would literally put 5 times. I know that this is going to be a 2y, okay? And I know that this is going to be a y. I also know a couple other things. I know that because this is minus plus, the only way to multiply and get a positive, add and get a negative, is if this is minus and this is minus. So then I need the two numbers that'll multiply to give me 6. Now here, I got to guess where to put them. It's 2 and 3 or 6 and 1. I'm not sure which. So the easiest thing to do is just start guessing. Okay? If I guess 2 here and 3 here, I get negative 2y in the middle. I get negative 6y on the outside. That doesn't work. Okay? So I'm going to change them. I'll put 2 here and 3 here. And then, just by looking at my FOIL, negative 3 times y is negative 3y. 2y times negative 2 is negative 4y. Negative 4y plus negative 3y gives me my 7. That may sound confusing for some of you. That's okay. If what I did over here is confusing, continue to use this method over here. The more of them you do, the better you get. You'll be able to skip steps because you'll be able to do the problem in your head or do the FOIL, the unfoiling in your head to check your answer. Alright? If that part confused you, go ahead and go back, watch the video again. Use the same concepts from 2A to do the problems in 2B. Let's take a look at the next one. Sometimes polynomials can't be factored. If I told you to, find all the factors of 13, it's just 1 and 13. So we can have a prime polynomial in the same way that we can have a prime number. 4x squared minus 3x plus 5, for example. Take a look at those. There's the factors of 20, 4 times 5. There are no factors of 20 that add up to the middle number. No factors of 20 that add up to negative 3. So there's no factors here. If we take a look at these problems at the bottom, 4 times 7. 4 times 7 is 28. So let's list the factors of 28. We have 1 and 28. We have 2 and 14. We have, what else? I'm waiting. 4 and 7. There's no way, even if we change all of these to negatives, there's no way these numbers are ever going to add up to negative 1. So that's a prime polynomial. Let's take a look at this one just to be sure. 2 times negative 5 is negative 10. So let's find factors of negative 10. We have 1 and negative 10. We have 2 and negative 5. Uh-oh, look what I noticed. This one I could factor. If I make this a negative 2 and this a 5, that adds up to 3. So this one over here, we could factor. Right? This one, we can do. So let's go ahead and do this one on the right. We have, and I'm going to jump straight to the answer for those of you that like that. I'm going to set up my parentheses. So there's the left one, and there's the right one. I know that this is going to be 2x, so this is going to be x. And then there's only really one way to get to negative 5. It's the positive and a negative. So we got to use these two right here, negative 2 and 5. So let's see. Let's just guess. Let's put the negative 2 here. Wait, I'm sorry. we're going to change this, but there's only one way to get to -5. It's -1 and 5. And that's what we're multiplying to. So -1, let's just guess that and see what we get. And we'll put +5 here. Let's guess that and see if that works. We have 5 times x gives us 5x. 2x times -1 gives us -2x. 5x minus 2x gives us 3x. So that way, that one was factorable. You have to check and make sure. You never can be sure unless you check your answers. All right. And again, we could FOIL this and check to make sure we've done it right, or you could use your graphing calculator if you preferred that. We also need to take a look at dividing polynomials. Okay, let me make this a little bit bigger. So dividing polynomials, the first example shows us if we had 6m plus 36 over 6. What you're able to do is you can just separate. Okay, you can separate this as two fractions, 6m over 6 and 36 over 6. When you do that, you divide one at a time. We don't cancel because I don't know what that is or what that means. But we divide this, that's 1m, and that is 6, and it's really just as simple as that. We can make them more complicated by adding letters, by adding exponents, like in example 1b and in example 2, but it's still just the same thing. The key is that every time you separate, and that is not what I want. The key is that every time you're going to separate, for example, right here, let's turn this. This is going to be 2x to the fourth divided by the denominator. Okay? And then you're going to have to do the same thing for each term. This needs to be -8x cubed divided by the denominator. Okay? And this drawing is getting confusing. So let's get rid of those. Those are ugly and goodbye. Let's do, it's -2x fourth divided by -2x squared. And then you're also going to have to do -8x cubed divided by 2x squared. And you're also going to have to do 4x squared divided by 2x squared. And you're also going to have to do y squared divided by -2x squared. Okay, and that's what we've drawn out here. You have to separate it and do each one, and then you get your answer. Okay, you get a simplified answer. There are some practice problems on here. I'll give you, if you're watching this on the video, please pause it right here so you can take a second and work through these problems. Okay, so hopefully you paused it right there because we're about to take a look at our answers. If you haven't paused it yet, you need to pause it now because here we go. In this first term, we're assuming, by the way, it says assume no denominator equals 0. We assume that because if it did, we would have an undefined number that you can't have a denominator of 0. So 5y squared over y is very simply 5y. Y squared over y is y. This is review from some of this from dividing exponents. 8x squared over 2x squared, well, the x squareds divide to 1, and then it's just 8 over 2, which is 4. 8ab squared over 12ab, the a's divide to 1, the b's, we're going to have a b on the denominator, and then 8 over 12 needs this to be simplified. 4 goes into both, so that's 2b over 3. Here is where we get into where we need to start separating them. So one at a time. 4a over 4 is going to leave us with a, and 12 over 4 is going to leave us with 3. So we do each one at a time, and we're left with a plus 3. Here we have 20n minus 16 over 4. 20n over 4 is 5n. Negative 16 over 4, you guessed it, 5n minus 4. 8xy minus 12x squared over 4x leaves us with 2y minus 3x. 50a squared plus 10a over 10a. Be very careful. Students a lot of times go, oh, 10a over 10a, 0. But any number divided by itself is always 1. And on the bottom one, the number 8, we're left with 2b minus 3a. If you need help with any of these problems, please see Mr. Nemro, or feel free to watch the video again. Try showing your work. Try not to do it in your head. Try not to hit your head. Things like that. Those are all good tips. Let's take a look at the next page. These are more practice problems. I'm going to let you work on those in groups, if you could right now, and then go ahead and pause the video, work on groups. We're not going to go over these right now. We'll go over these the next class. So pause the video, go ahead and go over those or work on those in groups, and we'll work on, or we'll look at the answers to those next time. Alright, so hopefully you've just finished working in groups, and now you're ready to look at how to factor, do polynomial division. Okay, polynomial division. And what this is we know how to multiply numbers using the grid method. Okay, we know how to do that. We looked at that, the Punnett square concept. Okay, let's go ahead and do a review of that. If we're going to multiply 3x to the fourth plus 2x squared minus 1 times 5x cubed minus 3x plus 2. Let's go ahead and do that in this grid right here. You can go ahead and work on this as I work on it. You can probably type a little bit, or do this a little bit faster than I can type it. If you can't, well, then you're in luck, because I'm going to go slow. So 3x to the fourth. Here we have 2x squared, and then minus 1. I'm going to go ahead and make all my terms, then I'll put them in the boxes. You're probably not doing that unless you're working on a Promethean board of your own at your desk, which if you are, that is really weird. I'll put these in here. Fantastic. All right, here we go. So 5x to the fourth, or 5x to the third times 3x to the fourth is 15x to the, that's right, 7th. Okay. 2x squared times 5x cubed is 10x to the 5th. And 5x times negative 1 is negative 5x cubed. Alright, so there's all those. I'm going to just make these all a tad smaller so they fit nicer. Don't you wish you could do that? I know, I'm awesome, you're welcome. Alright, so, what size is that, 20? Okay, so now let's go ahead and negative 3x times 3x to the fourth would be negative 9x to the fifth. So there's that. 2x squared times negative 3x is negative 6x cubed. And negative 3x times negative 1 is 3x. So there's that. Then we have, we're multiplying everything by 2. So this is going to be 6x to the fourth. This is going to be 4x squared. And this is going to be negative 2. Alright. Then we have to go through, let's find our like terms. Okay. 15x to the 7th doesn't have any like terms, so we can just say that that is going to be part of our answer. 10x to the 5th and negative 9x to the 5th, those are like, when we're left with, what are we left with? Well, we're left with just 1x to the 5th. Okay, so let's pull that over here. So we have other like terms now. We have, we took care of the fifths. Now we have 6x to the 4th. So we're just going to pull that over here. And again, this is review. Probably some of you are like, this is way easy. Why are we doing this? We're just doing it to make sure, because in a second, what we're going to do is we're going to undo these. We have two x cubes, so we're going to combine those. Negative 6 plus negative 5 gives us negative 11. And then these are all just, these come right over. Plus 4x squared. Plus 3x. And then minus 2. So if we can multiply using this technique, it would make sense that we should also be able to divide using this technique. So let's take a look at these. Division and multiplication are inverse relationships. So if we have x cubed plus 2x squared minus 5x minus 6 divided by x plus 3, the first term of the numerator, the product, x cubed, goes in the first box, right? So we know that we're dividing it by x plus 3. So we know that this is x cubed. If this is x cubed, what would go here? Well, the only way to get x cubed, if we're multiplying something by x, is if x squared goes there. Okay, so this is kind of like a puzzle that you're going to put together. Then, using multiplication, we can multiply x squared and 3, and we know that this box is 3x squared. It's really simply just a puzzle that we're trying to put together. Now we have a 3x squared. Well, we really need a 2x squared. Okay, we know that because that was what was in the original problem, was the 2x squared. That's why we're saying we really need a 2x squared. So if we really need a 2x squared, how could we get 3x squared plus blank equals 2x squared? Well, a negative x squared. So if we have negative x squared, the only way to get that is if this term on top is negative x. If this is negative x, we're able to multiply these two and get negative 3x down over here. Then we go to the next piece of the puzzle. We really want a negative 5x. So if this is negative 3x, what could go here? Well, negative 2x. Then we use our puzzle piecing skills again. If this is x and this is negative 2x, what would go here? So x times what is negative 2x? Well, x times negative 2 is negative 2x. And then negative 2 times plus 3 is how we got our negative 6. And we can really quickly just look up to the top and check. Yeah, we had a negative 6. We got negative 6. That's the one we wanted. So there is no remainder. You remember remainder from when you learned how to divide. So if we have x cubed plus 2x squared minus 5x minus 6 divided by x plus 3, our answer is x squared minus x minus 2. Seems complicated. It goes a lot faster, obviously, because you wouldn't draw a new box each time if you were doing it. But it's a really easy way to use the grid method to divide polynomials. So you try. Fill in the boxes at each step. So go ahead and here's another example that we walk you through this. Now this time the only difference is when we get our whole way through it, we do have a remainder. Okay, we have 10 down here on the bottom, and our constant term is a negative 8. Okay, so our remainder is negative 18. Negative 8 minus 10. Okay, so we have negative 18 right here. That's our remainder over x plus 2. All right. Another example. Okay, sometimes when we divide, we work our way through this whole problem and we get to negative 20. All right, negative 20. Well, 25 minus 20, or negative 20, negative 25 plus 20 leaves us with negative 5 as our remainder. So we always put our remainder over what we were dividing by, and our remainder here is negative 5 over x minus 2. Just two more examples walking you through how to do these kind of problems. So go ahead and take some time here. You try this one. Try it in groups, see if you guys can get to an answer. I'll give you some time to work on that. We'll go over this answer in class next time. There's also homework. Okay, the homework is, and this is page 496. Let me make sure that's right. Yep. Page 496, and we'll just go ahead and say, since you already have some practice problems on the other page, let's do 1 through 21 odd. Okay, page 496, 1 through 21 odd. Okay, go ahead and do those, and then your the other practice problems that were there. So let's make this bigger so that you can't say I didn't do it because I couldn't see it. Okay, page 496, 1 through 21 odd. Go ahead and do those, and then if you need if you don't have the book, you can just pause the video right here and do those. And then there are some more practice problems for you here on division. Are there a lot? Yes, there are a lot. Am I apologetic for that or sorry for it? No. If you think you're pretty good at these, just do the odds. Okay, if you want some more practice, go ahead and do all of them. We'll go over all of these in class. All right, so there's your homework, those 2 pages. Next class, hopefully we're going to be ready for ready to review, basically. So we'll review the last unit, we'll review this unit, and then we'll take the test on Friday. Okay, if you have any questions, please feel free to watch the video again. It's posted on the class webpage. Have a wonderful, super duper day. Oh, one more thing. If you have questions, please see me during Flex. I know that we don't all see each other every time during Flex, but you're welcome to flex in anytime. Thanks. Have a great day.